Hello and greetings to everyone who has joined the class. I'll be teaching you measurements and instrumentation. The objectives here are why do we need to measure a quantity? How do we measure a quantity? What are the different units that we use while measuring a quantity? What are the different instruments that we use when we measure a quantity? And how the process of this measurement has evolved over time. Now, measurement, as you already know, means that we quantify a quantity, and that particular quantity can be either mechanical, electrical, chemical, physical, or anything in nature, and we need to measure it. So, like in earlier times, if we had to measure the distance, how did we measure the distance was how many days it would take us to say move from point A to point B on whatever means of transport, say a horse or whatever, say a cycle, it would be at that point of time. So say if it would take me 3 days, I would say the distance is 3 days from point A to point B. Or say if I want to measure the quantity of liquid or say volume, how would I measure that? By the number of glasses I take out of a bucket, or say how I fill a pit by the number of barrels of water. So those used to be the quantities or how we quantified certain quantities at that point of time. But with the advent of time, the means by which we measure a quantity has changed. Also, since there have been it's like say in one place I measure a certain quantity using some specific unit. Say I measure liquid quantity by using a glass, but somewhere else they use a barrel or a bucket to measure the amount of liquid that we are using. Okay, so that was not they did not confirm with each other. So what we needed to do was I should have the same unit and the other person using measuring the same quantity should have the same units. So there was a standard body which kept certain specific standards for measuring a particular quantity. Okay, like we already know we have certain fundamental quantities like length, mass, time, current, temperature, luminous intensity, and quantity of matter. Okay, so if I have to measure now the length, okay, so we all know length has a basic unit, or we can say its fundamental unit set by a particular body is what? Meter. Okay, and then another fundamental quantity that we are having is mass. Mass is measured in kgs. Okay, then another fundamental quantity is time, and we measure this in seconds. Then fourth is current, and its unit is amperes. Then fifth is temperature, and we measure it in Kelvin. Luminous intensity, unit being candela. Seventh fundamental quantity being quantity of matter, and we measure that in moles. Okay, so these are the fundamental units. Okay, we have other derived units, like we have say we can say force, and we already know force is equal to mass into acceleration. Okay, so whatever are its units, that will be based on the units of mass and units of acceleration. That is very basic. So mass being measured in kgs and acceleration meter per second square. Okay, so force has unit kg meter per second square, or this is also called as Newton. So these are certain derived units, but these are not the basic unit. The basic units are for basic quantities, which are these seven, and these are the units. Now that specific body that defines these units, say meter, Okay, so always, no, we do not use meter. We sometimes use kilometers, sometimes we use nanometer, millimeter. So what do? Is these units we use prefixes along with them to either increase its magnitude or decrease its magnitude. Similarly with other quantities also, milliseconds, nanoseconds, with amperes also, milliamperes, and like that. So this unit that which gives them the units meter, kg, second. This is SI system of unit, and this is standard over the entire globe. So how does it help us? SI, what are the advantages of using SI unit? This is a coherent system of units based on fundamental units, or we can say that there is we do not have to use different units for a same quantity. Say, like I have already said, that if I want to measure a longer distance, I will use kilometers instead of meters. If I have to measure very small distance, I would use, say, millimeter or picometer, nanometer, and stuff like that for measuring the unit. Okay, and then it is a rational system of unit. Means what? Say, like if I'm talking about SI system, the unit of energy, it is joules. Okay, but if I talk about other systems, say MKS system, then for different types of energies we have different units. Like if I'm talking about mechanical energy, its unit is joule. If I'm talking about heat energy, then its unit is calories. If I'm talking about electrical energy, its units are kilowatts. So for other system of units, if I'm talking about different types of energies have different units, but here any type of energy has the same units, which is joules. Okay, also these are used in it applies to all the branches of science. So these are certain advantages of using SI system over other systems. Okay, so whenever we are talking about units, or mostly whenever we are measuring any quantity, we are going to use SI systems for that. Okay, SI system for that. Okay. Next, we are talking about what are the various standards of measurement. Okay, standards of measurements. A standard is a physical representation of a unit of measurement. A unit is realized by reference to an arbitrary material or a natural phenomena. So, these standards are broadly classified into four types. Okay, the first one being international standards. Then we have primary standards. Then we have secondary standards, and last being working standards. अब ये चीज़ होती क्या है? इंटरनेशनल स्टैंडर्ड्स वो स्टैंडर्ड्स होते हैं, या फिर वो एक बॉडी होती है जो बनाती है किसी भी स्टैंडर्ड को, और उसे एक स्पेसिफिक जगह पे they just keep it preserved at a particular place. And in the world we have just one place where we store, or where we preserve the international standards, and that place is International Bureau of Weights and Measures. So it is International Bureau of Weights and Measures, and it is in France, Paris. Okay. So what do these people do? Say if I'm talking about meter. meter, how much is the length of 1 meter, how we define it, 1 meter की length कितनी होनी चाहिए, that is being devised by these researchers after certain conferences, and then once they come to a common conclusion, they define a particular standard and they preserve it in International Bureau of Weights and Measures. और यहाँ पे जब इसको प्रिजर्व करते हैं, सो दे आर मेजर्ड विद द हाईएस्ट लेवल ऑफ एक्यूरेसी विच इज पॉसिबल कंसर्निंग दी प्रेजेंट टेक्नोलॉजी. जैसे फॉर एग्जांपल पहले केजी का एक यूनिट होता था, केजी हम कितना वेट लेते थे, दैट यूज्ड टू बी अ सर्टेन platinum cylinder which was being maintained at International Bureau of Weights and Measures till 2018. After that, when scientists, they held a conference and they discussed and they thought that this standard needs to be revised, and now there is a revised unit of kg. Now it is not based on that the weight of that platinum cylinder which was preserved there. Now it is based on Planck's constant. Similarly, if I am talking about other units, say length हम 1 मीटर कितने को define करते हैं, how much length is of 1 meter, it is actually how much distance light travels in 1 meter. You define 1 meter as how much distance light travels in 1/299,792,458 seconds. जितनी distance light travel करेगी in this fraction of second, that amount of distance is defined as 1 meter distance, and again that is being defined by a body which works at a place which is International Bureau of Weights and Measures. Similarly, we have a definition of second and like that, which is properly under certain set of rules which is discussed and which is kept with the maximum amount of accuracy and precision. Now, what are the other three standards, which is primary, secondary, and working standards? Now, talking about if I talk about the priority or preference in which they are accurate, I will say international standards सबसे ज़्यादा accurate है, उसके बाद primary standards, then secondary standards and working standards. It is not that working standards जो है they are not at all accurate, they are very accurate, but if we compare to the secondary standard, they will be little less accurate. Then if we talk about primary, they will be little more accurate as compared to secondary, and like that. Now, working standards वो standards होते हैं which we use in our laboratory on day-to-day basis. Say if you are measuring a resistance in your laboratory, how do we measure the resistance in laboratory? Is using a Wheatstone bridge. तो वहाँ पे जब आप 4 resistances लगाते हो, out of which 3 are known and 1 is unknown, that one unknown resistance, say this is the unknown resistance that you measure. When you measure it, that becomes your working standard. Okay, whatever quantity that you measure in your laboratory, that becomes your working standard. Now, what are secondary standards? Secondary standards जो है, they are used for calibration of working standards. So now say यहाँ पे ये हमारे जो थे, ये हमारे known resistors थे. Whenever you take your certain resistors which you use in your Wheatstone bridge, whose resistance is known, how do you measure their resistance? They are already measured because they are developed by certain industries, and those industries they develop it using secondary standards. So already जो हमारी industries कोई भी हमें rated value देती है, चाहे capacitor का, resistor का, किसी और चीज़ का, they are under secondary. They come under secondary standards. Now, what are primary standards? Primary standards hai, since we have just one international body where we have defined previously the standards, that is International Bureau. But if we want to have or if we want to check some primary standard or secondary standard or working standard, we will not go to that particular country just for checking the accuracy of that standard or that particular quantity. quantity. In that case, what we would do, there are certain national bodies which function in a country, okay? Like for example, if I'm talking about, say we have another institution which is National Bureau of Standards, which is in Washington. Similarly, we have other bodies working in different countries. These are also constructed for the greatest possible accuracy, and their function is checking the accuracy of the secondary standards. So primary standards are actually maintained at institutions in various countries around the world. Okay, like for example, National Bureau of Standards, which is in Washington. Secondary standard, I've already said, they are used by industry people for checking the working standard, accuracy of working standard, or they give us these materials that we use and they are based on secondary standards, and then whatever measurements that we do in our laboratory on daily basis, that is our working standard. So these are different standards which we, so these are different standards of okay. So now, after discussing various different standards of measurements, we again come back to the basic definition of measurement. So measurement, if by now we can define measurement as a process by which one can convert a physical parameter into a meaningful number. Okay, meaningful number that quantifies that particular physical, chemical, or electrical quantity. Obviously, whenever we are doing a measurement, it is done using a particular instrument, and that particular instrument is the measuring instrument of that particular quantity. For example, if we have to measure length, we'll use a scale or either a meter scale or a tape or whatever we are convenient with. Okay, say if we are if we are measuring current, so we will need an ammeter to measure that current. If we are measuring voltage, we need a voltmeter. So this voltmeter, ammeter, measuring tape, all these are our measuring instruments. So measurement can be either direct or indirect. For example, if we have to measure the length, we'll directly hold the meter scale or whichever scale we are using against the against whatever components length we have to measure. Okay, and we'll keep it against that and we'll write its measurement to be the multiple of the length or multiple of meters, how many times we have to multiply that quantity or meters so that we can have the length of that particular quantity. So when we directly use, say, an inch tape or a scale, say I have to measure the length of this notebook, I'll keep a scale here and measure it. Okay, so we are doing that kind of measurement is direct measurement. Okay, and we have an indirect method of measurement. Okay, so measurement can be done either directly, so that is direct measurement, or indirectly, that is indirect measurement. Directly, for example, we are measuring the length and we'll keep the inch tape or a scale. Say I have to measure the length between this point and I will keep a scale here and I'll measure it. So this comes under direct measurement. And indirectly, say if I have to measure current, so current is measured by the deflection of the pointer. ठीक है, और मोटर एक्शन के थ्रू हम एक पॉइंटर की डिफ्लेक्शन मेजर करते हैं एंड देन वी कम टू नो अबाउट the current. So ammeter is, or measuring current is how we measure indirectly. या फिर अगर मुझे resistance measure करनी है, say I will measure the voltage, I will measure the current, and then I will take their ratio and then I will have the measurement of the resistance. So if I have to measure current, resistance, or anything, that comes under indirect measurement method. Okay, so there are two ways where we can measure things or quantities, that is direct measurement or indirect measurement. Now coming to the classification of the instruments. Instruments, as we have already said, that measuring instruments are the instruments जिसके against हम एक quantity को measure करते हैं. So now if we have to classify Measuring instruments. There are various ways in which we can classify the measuring instrument. The very basic being, so first classification I'll take say is, we can classify them as electrical instruments and electronic instruments. Now, how do we classify instruments into electrical or electronic? So, your electrical instrument is that which is based upon the mechanical movement of electromagnetic meter to measure, say, voltage, current, etc. So that comes under the electrical measurement or electrical measuring instrument. That means, say, this is your analog say voltmeter varying from 0 to 10 volts. So the deflection of this pointer from 0 to 10, it is whatever whichever. So this instrument, this can be classified as your electrical instrument. So in this, obviously the motor action is taking place. These electrical instruments, these are also called as D'Arsenal instruments, or kind of, they are also analog instruments. Now, what are electronic instruments and what is the need for electronic instruments? Now, with electrical instrument, we say that, say, I'm talking about a voltmeter. Here I have taken the example of voltmeter. Now here it is taking voltage from 0 to 10 volts. Now say if I have to measure a voltage which is of the range of, say, millivolts, okay, or microvolts. So in that case I can also use microvoltmeter, okay, or millivoltmeter, but the precision or accuracy of that kind of voltmeter is very less. So what is the other preferable method I can measure the small amount of currents or voltages with, is by using an electronic voltmeter or an electronic ammeter, electronic voltmeter, EVM, or an electronic ammeter also we can use to measure the small amount of current. So what is the basic principle of this working of these electronic voltmeter? This is the same D'Arsenal instrument, but before this we have amplifiers. So amplifiers plus your electrical instrument or your D'Arsenal instruments gives you what? Your electronic equipment. So if somebody asks you what is the difference between an electronic instrument, electronic measuring instrument, and an electrical measuring instrument, the difference is only of the amplifiers. So your amplifier is actually your any electronic circuit as in which is active electronic circuit. It can be an amplifier based on a transistor, based on a field effect transistor, or anything like that, okay. So both are basically based on the movement of electrons, okay. So but in this case we are using an amplifier. An amplifier in this case is actually an electronic circuit which is an active electron device like a vacuum tube, semiconductor diode, or an IC, or whatever is there, okay. So amplifier plus D'Arsenal instrument or electrical instrument gives you an electronic instrument. The importance, or we can say the advantage, of an electronic instrument over the electrical instrument is what? It is more sensitive. So it increases with the addition of the amplifier circuit along with this D'Arsenal instrument. It increases the sensitivity of the instrument, so they are more accurate as compared to your electrical instrument, because they can even detect the smallest amount of current or voltage or any of the quantities, okay. So now if I have to take the second classification of measuring instrument, that is, they can be either analog or digital, okay. So analog meters or analog measuring instrument use analog signals to display the magnitude of quantity under measurement, and this uses digital signal to indicate the result of the measuring device in digital form. Also we can say that here you can use an analog signal and the readout is Here in that case the readout is analog or deflection or of pointer system. Okay, and digital instrument is what? Digital instrument जिसमें हमारा जो readout है वो digital है, that is it is in the form of digits 0 1 2 3 4. So if I have a digital readout, say I have, so this is your digital readout output and this is your analog. This is your analog readout output. Okay, so there are other instruments classified as, say, number one, indicating instruments. Now, what are indicating instruments? Indicating instruments are those instruments where you have a pointer deflection type of mechanism, ठीक है, और जो खाली आपको किसी भी चीज क्वांटिटी की, चाहे वो इलेक्ट्रिकल हो या फिजिकल क्वांटिटी हो, वो जस्ट आपको उसका वैल्यू बताती है at that particular point of time by deflecting the pointer from 0 to wherever the quantity lies. Okay, so that is an indicating type of instrument. Now then there is second category which is recording type of instrument. Recording type क्या है? जो आपको continuous बताती है, अगर कोई एक, say if I'm measuring a current, so current in a particular circuit mostly remains constant for a particular duration of time, but say if I have to measure heartbeat or something like that which varies over a continuous duration of time, जो continuously change होती जा रही है, तो उस quantity को अगर हमें measure करना है तो हमें साथ साथ उसको record भी करना पड़ेगा, क्योंकि एक point पे वो एक तरीके की हो सकती है और दूसरे point पे it changes very in a small instant of time, it changes and I need to record it along. So what is your recording type of instrument? So recording can be your oscilloscope, ठीक है, then or it can be your ECG जो आपको graphical output देता है, कोई आपको graphical output दे सकता है which can be either printed or it can be coming onto the CRT cathode ray tube या किसी भी screen पे display हो रहा है, but in both cases they are giving you continuous deviation of that particular quantity with respect to time or any other thing. Also it is recording that quantity and showing that. Okay, so next is you can have an integrating type of measuring instrument. So integrating type जैसे आपका वॉट मीटर है, ठीक है, या फिर आपका एनर्जी, सॉरी वॉट मीटर नहीं, एनर्जी मीटर जो आप घर पे यूज़ करते हो, जो आपको मंथली आपके चार्जेस जिस पे बेस्ड होते हैं इलेक्ट्रिसिटी के, आपने कितना कितना पावर कंज्यूम किया है, कितनी एनर्जी कंज्यूम की है, सो दैट इज़ डूइंग व्हाट, दैट इज़ एडिंग टू योर प्रीवियस यूनिट्स ओनली. So instead of just measuring the current values, it is also adding that to the previous value. So your energy meters are an example of your integrating type of measuring instruments. Then we have another category which is null deflection type. Again, since it is also an it can be considered to be a subtype of an indicating instrument, but here this needle lies in the center. 0 is your null. From here say we have -5 volt and the rightmost extreme is your +5 volts, so it can go here or here, center 0, or we can say these are null deflection type of instrument. Also these are indicating instrument. So mostly your what is the example of null deflection type of your measuring instrument? It is galvanometer. Then the last category is your controlling type. कंट्रोलिंग टाइप कोई भी जहाँ पे हम फीडबैक लेते हैं, वो कोई डिवाइस जो मेजर करती है, देन इट गिव्स यू द फीडबैक एंड देन इट करेक्ट्स द एरर. एनी ऑटोमेटिक कंट्रोल सिस्टम, ठीक है, any automatic control system which where you measure, say if I'm talking about an AC and that is regulating our room temperature and I want say 18 degrees Celsius in my room right now, so what it does is it senses your temperature. Okay, if it is greater than that, it takes the feedback, generates an error signal, and the internal circuitry, it tries to make the error equal to 0, and like that. So any of your say any computer, if you or microcontroller, if you use along with the sensing device, that can act as your controlling type of measuring instrument. Okay, so these are the different classifications of the measuring instruments. So now, once we are done with, by now we have understood what is measurement, what are the different units that we use for measurements, what are SI units, what are the various standards of measurement, what are different measurement techniques, what are the different measuring instrument classifications, what are measuring instruments. Now, obviously, whenever we are measuring something, we are always prone to errors. So, errors are a very important part of measurements and instrumentation. Wherever you are doing measurements, you are bound to have errors. So, error actually is what? Error is actually the deviation from the true value, okay, or true value or the rated value, that is called as error. So now we will be discussing errors in detail.